This video is going to be about long division of polynomials like this. But to prep ourselves, we're going to go through a number example first using a two-digit number. The reason I'm using a two-digit number is going to apply to this here. So when we look at something like this with numbers, instead of saying how many times does 32 go into, say, 78, you can often just say how many times does 3 go into 7. Doesn't always work, but at least that's a place to start. So this 3 goes into 7 2 times. Okay, and that's the first step of doing a long division, is to divide. So we're going to write those steps down, and then we'll apply these steps over here later. So we did the division. What's the next step? You guys know. You'd multiply. 2 times 30 is 60. And 2 times 2 is 4. 64. Okay? So that's the next step, is multiply. We'll write that down. Then the next step is to change the sign on this and add those together, or subtract. You probably used subtract together, before. But changing the sign and adding is the same thing. So 78 plus negative 64 is going to give us 14. Right? So that's the third step. We'll write that down, is to subtract. But with polynomials, we change sign and add. Okay? Then the final step here would be to bring down the last digit there. Continue to bring down digits, and then the cycle repeats itself until you're finished. So let's just finish this off. 3 goes into 14 4 times. Let's see if that works. 4 times 2 is 8, and 4 times 3 is 12. That leaves us with 20 as a remainder. Okay, that problem is finished except for the add-on here. We would add on a fraction of 20 32nds. Let's write that down here because we can reduce it. 20 and 32 both divide by 4, like that. And 20 divided by 4 is 5. 32 divided by 4 is 8. So the answer to that is 24 and 5/8, writing the remainder. When we write mixed numbers, there's a assumed plus sign here, even though you don't write it. And we will have to have a plus or minus sign over here, depending on what the sign of the remainder is. So now we're going to apply this technique that we went over with numbers to a polynomial division. Okay, I know it looks different from the one that was up here before, but we just spliced this together. Anyway, so I'm going to set up this division. This is what it's divided by, so that goes in the front, just like we're dividing by 32 there. X minus 2 goes here. We put a big long box there. And we're going to write this polynomial in here. Remember that there's a couple of things we have to be aware of. First of all, these have to go in descending order of powers. So what's the highest one? X cubed. That term has to go first. So we're going to start with 5x cubed. Next term has to be an x squared term, but there's no x squared term here. If that's the case, we need a placeholder. We need to put in 0x squared. And that'll be evident why that needs to be there as we move along. And then the next term, we got cubed, squared. First power would be this 3x term. And then the last one is the constant term, minus 4. So that's how we set that up. Be really careful to put in zeros for any power that's missing and have those powers go down by 1 each time. Okay? So now, we're going to apply these steps. We're going to divide x into 5x cubed. If that's difficult to see in your mind, you can write that off to the side. 5x cubed divided by x. And reduce that fraction. Well, x would divide into x cubed and make that power go down 1, or 3 minus 1 is 2, using those exponent rules that we learned before. So that's 5x squared. We're going to put that in its place above the like term, like a place value, like you'd put 2 here in the tens place. Treat this the same way. And 5x squared now gets multiplied. That's step 2 by x minus 2. We're going to distribute that. 5x squared times x is 5x cubed. And 5x squared times negative 2, negative 10x squared. Okay, now we're going to do the third step, which is subtract. With polynomials, we're going to change the sign and add. So we change these signs. This becomes negative. This becomes positive. And we add those two together. When we add 5x cubed and negative 5x cubed, they're going to cancel out. That's not a good way to think about it. Let's call it subtract to 0, or add. These terms are adding to 0. So when they add to 0, we don't need to write that, because 0 plus anything won't change that other thing. X squared plus 10x squared, no, 0x squared plus 10x squared is 10x squared. And we've done this third step. Now the fourth step is to bring down the next term, 3x. Okay? So we go back to the beginning and divide again. Divide x into 10x squared. We just have to think about those first terms, remember? And let's do that off to the side again too. 10x squared divided by x is 10x, because the x squared is reduced by x to x to the first power. So that's what goes up here. That's the division part. 10x. We multiply now, distributing that 10x across x minus 2. We get 10x squared minus 20x. Okay? And then we're going to do the third step, subtract, by changing the signs and adding those terms. Again, these first terms combine to get 0. So that 0 doesn't need to be written down. And 3x plus 20x is 23x. And bring down one more, the last term here, negative 4. And we're going to divide once again. X into 23x. Those x's divide to 1 and we get 23. So that goes up here. That's our division step. Multiply, 23 times x, 23x. 23 times negative 2 is negative 46. And again, we change the signs and add those together. 23 and negative 23x, again, add to 0. That should always happen. If it doesn't, you did one of these divisions or multiplications incorrectly, and you've got to go back and fix that. This adds to 0, so we don't need to write that. And the remainder here is 42. How do I know that's the remainder? Because this x will no longer divide into 42. Okay, just like 32 didn't divide into 20 here. Okay, so we've got our remainder. We write the last bit here, the fraction made from 42 divided by x minus 2. Let me put a real 2 there. And there's your answer.